The sequence of numbers in the first column of the solvet are values of a particular polynomial function. For such a sequence, you can use the patterns of first differences, second differences, third differences, and so on to learn more about the polynomial function. A monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. The degree of a monomial in one variable is the exponent of the variable. A polynomial is a monomial or a sum of monomials. The degree of a polynomial in one variable is the greatest degree among its monomial terms. A polynomial with the variable x defines a polynomial function of x. The degree of the polynomial function is the same as the degree of the polynomial. Take note, key concept, standard form of a polynomial function. The standard form of a polynomial function arranges the terms by degree in descending numerical order. A polynomial function p of x in standard form is p of x equals a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus, and the pattern continues, plus a sub 1 times x plus a sub 0, a constant, where n is a non-negative integer and a sub n through a sub 0 are real numbers. For example, consider this polynomial function p of x. P of x equals 4x cubed plus 3x squared plus 5x minus 2. 4x cubed is our cubic term, 3x squared our quadratic term, 5x is our linear term, and negative 2 our constant term. You can classify a polynomial by its degree or by its number of terms. Polynomials of degrees 0 through 5 have specific names, as shown in this table. So note we have degree on the left, 0 through 5, the name of the polynomial using its degree, an example of such a polynomial, the number of terms in the example, and then the name of the polynomial using number of terms. First, degree 0. We call that a constant. An example is 5. The example 5 has one term, and we call that a monomial. For degree 1, we call that a linear polynomial. An example, x plus 4. Note when we graph the function y equals x plus 4, we get a line, a linear function. Number of terms, 2. Because it has 2 terms, we call this example a binomial. Degree 2, we call that a quadratic polynomial. An example, 4x squared. Note this example has one term, so it's classified as a monomial. A third degree polynomial is referred to as a cubic polynomial. An example is here, 4x cubed minus 2x squared plus x. This example has 3 terms, so it's referred to as a trinomial. A fourth degree polynomial is referred to as a quartic polynomial. An example, 2x to the fourth plus 5x squared. Our example has 2 terms, so it's referred to as a binomial. And finally, a fifth degree polynomial is called a quintic polynomial. An example, negative x to the 5th power plus 4x squared plus 2x plus 1. This example has 4 terms, so it's called a polynomial of 4 terms. Problem 1, classifying polynomials. Write each polynomial in standard form. What is the classification of each polynomial by degree? By number of terms. First part A, 3x plus 9x squared plus 5. Rewriting the polynomial in standard form, we'll put the quadratic term first, 9x squared, plus the linear term, 3x, plus the constant, 5. And we can see this polynomial has degree 2 and 3 terms. So it is a quadratic trinomial. Part B, 4x minus 6x squared plus x to the 4th plus 10x squared minus 12. Rewriting in standard form, with the terms of highest degree farthest to the left, x to the 4th plus 4x squared plus 4x minus 12. The polynomial has degree 4 and 4 terms. so it is a quartic polynomial of 4 terms. Your turn, part A. Write the polynomial 3x cubed minus x plus 5x to the 4th power in standard form. What is its classification by degree and by number of terms? Part B. Write the polynomial 3 minus 4x to the 5th plus 2x squared plus 10 in standard form. What is its classification by degree and number of terms?